Hello my friends, welcome back to the work basement. Today I'm getting started on a build of 4 of my model called the Stella. It's a very big chef's knife, it's almost a sword. It's 240 millimeters long by 60 millimeters high at the heel, and these are an AEBL stainless. The stock is about 3.5 mil thick, it's just over 1/8 of an inch. They're pretty heavy right now, but the last time I made this model was in Alabama, Damascus, and I saw about a 40% weight reduction doing a full flat grind down to 0. So these should lighten up pretty significantly. Before I get started on any of the work though, a few videos ago I mentioned that I wanted to grow divide by categorizing my actions into one of 3 main buckets. Making functional tools, making elegant art, and growing the business in terms of sales and marketing. So here I have one specific focus in each of those buckets that I want to share during this build. And the first is straightening a blade after heat treatment. It's a very common problem that blades will warp or twist or bend in some way when you harden it. 2 of these knives are not too bad. The margin is small enough that I could correct it with grinding. The way I do that is using my height gauge. On each side I mark a center line and do my best to grind out any slight warping. But 2 of the knives have a significant warp. It's about a 50 or 60 thousandths of an inch bend to one side, and that's just way too out of spec, A, for the price that I hope to ask for when I go to sell these, and B, to maintain the profile while I'm trying to correct that. So here's my solution. That cost me $35, which was a great tip from Alex at Outdoors 55. This is a $15 16-ounce ball peen hammer, and this is a $20 3/16 carbide ball. I'm going to drill a hole into the ball peen and JB weld the carbide ball in here so I can use this as a ball peen. A lot of guys will correct a significant warp either with some kind of jig and retemper or grinding like me, but I'm going to give this a go because that's going to be hopefully a cheap and easy solution to make sure my blades are as straight as possible to really dial in the cutting performance. The second bucket is art. It's got to look nice. So I've got 2 sets of beautiful wood here. I've got stabilized purple curly maple from Maritime Knife Supply, and I've got stabilized ebony from Canadian Knife Maker Supply. I love both of these woods. And I'm also going to do a brass bolster on all 4 of them. And with the brass bolster, typically what I've done before is, like many knife makers, drill a bunch of undersized holes with my drill press and then come in after with a rotary tool and a needle file to dial in the fit. The 2 downsides to that method are it takes a bloody long time and it's never perfect. You can really see a lot of gaps on the fit up, and if you do have to hammer it on to kind of dial in the fit, it bends the brass, so it just never looks great doing that method. So similar to making sure that the blade is straight, it's got to look nice to have a premium price attached to a premium knife. So what I've done is I've ordered a small jig to add to my benchtop drill press to convert that into a mill. Basically it's got 2 compound slides with like a 3 or a 4-inch range, so it's not very much, but it should be enough to hold a piece of brass that's 1 or 2 inches thick, or wide, excuse me, to mill in a perfect slot. So I hope that I'll be able to do that using 2 hands, but we'll see. If I can, that'll save a lot of time and it'll really have a good fit up to make sure that these knives look the best that they can. And regarding sales, with these 3 knives, I'm only going to finish one of them all the way. I'm going to stop at about 90-95% with the other 3 because I've got these 3 pieces of steel that I'm going to use to try and help me sell them. We'll get there. Let's get after it. First step is going to be to grind a small flat so I can punch and then drill a 3/8 hole. Well, this is apparently pretty hard steel because I just broke 2 punches. After punching, I tried drilling and I snapped 2 drill bits and barely made a dent, so I took it outside with my map torch, and using science, I've tempered just the tip down so that hopefully this will be easier to drill. Good news, bad news. The temper did help. I was able to drill it, but my hole is off center by about 1/8 of an inch high and left. Don't think that's a huge deal. It's not really precision work. The ball still sits pretty proud. So I'll get this JB welded in, and then I'll show you how bad those 2 blades are warped. This is the worst one out of the 4, and you can see it's pretty warped. So if you push down on this end, and we can measure to the bottom, and it's actually about 80 thousandths. So pretty significant. While the JB weld is setting, let's talk about the theory and how peening is supposed to work. So if we have the table here and my curved knife in the angle we were just looking at, where it's low in the middle and high on the ends, this is the concave bend as opposed to a convex, which would be the other way around. So we want it low in the middle, and we're going to strike on this side into the bowl. And the reason for that is because it's a solid material. If you have something like corrugated cardboard or something softer, as you push it, you're not actually deforming the material, you're just moving the air around it. It's the structure of the corrugation that's kind of deceiving. It's going to deform around the force, but the metal is solid. So if you look at the cross section of the knife, if you leave a bunch of hammer marks here, the material will expand on the top relative to the bottom. So if you imagine kind of like a wooden ship on the outside absorbing water and expanding there, or a bunch of meteors hitting a planet, that material will expand. So as you strike this side, it should lower those high points down and end up with a flat blade. It's been a couple of hours that I've let the JB weld set. In that time, I've got this one blade almost done grinding. It was straight enough for me to do my usual method with the height gauge, and I've got the edge thickness to about 5/1000ths of an inch on a 120 grit finish, and I took in the tang just a little bit to just under 1/2 an inch because I'm going to use a 1/2 inch dowel to set this into the wooden blocks later. I'll show you that after. If you can't tell, this one is riddled with peen marks because I'm impatient. And I realized that a 3/8 bearing in a 3/8 hole with a certain depth, it's not going anywhere. The epoxy's really only keeping that from coming out. And having never done this before, spending a few minutes just trying this randomly, I'm extremely impressed with the result. It is way better than what it was when I started. I think this one's actually straighter than the one that I started grinding on. So for a $35 solution to ensure that my blades can now be fully straight, I'm very pleased. And if you're curious about the weight reduction, the unground blade, 334 grams, 333, and the one with a mostly finished full flat grind, 213 grams. So pretty much bang on 120 grams reduction just in the flat grind, and I'm not done yet. This knife here was the worst one out of the bunch. I've got 80 thousandths written on here because when you press down on the tang, that's how far the tip rises off of the flat surface. So I'll show you what it looks like to peen it straight, and hopefully we can end up with a nice flat blade. So after just 2 minutes, the back end is pretty much flat, and the front still has work to do, but it's definitely improving. So the back 2/3 is bang on, no movement. I've just got to continue here, and I don't care about the marks because this is going to be the full flat grind. I'm definitely going to grind through these peen marks. I've just realized that with the round peen, Every time I strike, there's a small amount of force that's distributed equally around that strike point. So if I hammer in a line, the net effect will be folding down perpendicular to the line that I hammer in. I've just flipped it over and I realized that there's a bow this way, so I'm starting to hammer longitudinally with the blade, and that's actually worked out pretty well. So I started out with the 80 thousandths warp, and I'm barely moving now. So after just a few minutes, huge improvement, and I'm going to grind through these peen marks when I do my bevels. Amazing. These 3 blades now have next to no warp, which is fantastic. The bevels are the boring part and aren't the purpose of this video, so I'm going to get that done off camera, and I'll meet you at the drill press when I'm ready to start fitting up the bolsters. I've got the bevels done and the majority of the hand sanding finished as well. These are sanded up to a 400 grit rough finish, and this one here is completely done. So everything is rounded, everything is sanded, smooth and polished, and my logo is etched into it. This one's ready for a bolster. Something I want to note is how thin this knife is. It's got a full flat grind that's really clean all the way from the spine to the edge down to basically 0. There's no reflection you can see along that cutting edge. And this has no cutting edge on it. It's only really thin. And look at that. So just one of the benefits of a high performance and expensive kitchen knife is the cutting performance is going to be fantastic. It took me a full day to get all 4 bevels done and this hand sanding. It shouldn't be too much more to get the sanding done on these, and I'm not going to etch these. I'll get into that a little later. But this one is ready for a bolster, which is perfect timing because look what just showed up. Okay, lovely. We have a new tool in the shop. Let me introduce you to Mr. Crossvice. This cost me about 110 Canadian dollars, and it's not perfect. It's a little sticky on the slides. I'm sure I can grease or lube that, and there's about a quarter turn of slop. But that doesn't really matter to me because I got this for a singular purpose: to improve my brass bolsters, both in quality and in speed. So here's my thinking. I'm going to clamp in my brass on the parallel sides because I buy flat stock. And I'm going to use my right hand to operate my drill press and my left hand to operate the slides with a 1/8 end mill in the press. And this is the same diameter as the width of my tang. So rather than what I used to do, which is trying to drill holes and then file out a slot, as you can see, this is some rough cutting, but it's never perfect. So I'm really hoping that this will help. My drill press lives in the other room, but the lighting in there is horrible, so for the camera, I'll bring it in here and we'll try it for the first time to see if this was worth it. Here's the setup I think is going to work. I've got the vise clamped down to the drill press using these 2 C-clamps that have a lot of clamping pressure, so this is actually really solid. I thought this would be a temporary solution. It might be a permanent one, because this is super convenient to move around. So with my first bolster, I've got my roughed-in center line. That's not overly important. I'm 1 inch wide by about 1.25 inches tall, which gives me a lot of buffer around the perimeter. I'm probably going to end up around 1 inch by 3/4, so I'm going to reference my slot once that's milled in. But because this is a uniform width, I can use 2 other pieces as a rest, and then I'm going to mark out 2 lines for the height of my tang. So this one is 490 thousandths, which is about there. This is all kind of ballparking for now. I've got a reference point up in this corner just for myself. So I'll scribe that line. I'll tear this, set it to my tang height of 490. And mark it again. So I'm going to set this into my vise and make sure that the mill goes up and down and just kisses those two lines, and I'm about 10 thousandths over an eighth of an inch on my tang. But the beautiful thing of this is not only can I go forward and back, I can also go left and right. This moves in X and Y. And because this is a fixed system, relatively, I don't need really high levels of accuracy. I'm able to take this out and put it back in and probably be able to mill just fine. Wish me luck. Just shifting it to the back here to give myself more clearance, and I've got the spindle speed at the lowest setting. I've moved the belt to the bottom, which is 620 RPM. So we'll get this clamped in. And one more thing before I start is I really want to reduce the margin of error, my number of variables. So I've got a height stop on the side that I can set so I don't have to worry about the pressure I'm applying downwards. If I have too much force, my bit can snap, so that will allow me to only have to focus on moving the slide. If I need to make a deeper cut, I'll lift up, adjust the height, and go back down and do it again. I've got my Tap Magic on reserve. I don't know if I'll need it, but here goes. The chatter was pretty bad at the end, but I think changing up my spindle speed and my depth of cut will help. But this is still way better than what I was able to do before. And that took 3-4 minutes. So the width is pretty good, and I need just a little bit more in height. Look at that. Okay, this one is going to be no good because I've overshot the width by quite a bit, actually. But the one thing that I've noticed is that taking it in and out of the vise, it stayed parallel with clean lines. So that's just user error. This works really well. In my learning curve of this new setup, I had to sacrifice 3 of the pieces of brass, but by just the 4th one, I was able to do this, which again, isn't perfect, but is definitely better than the old handwork I used to do with just the drill press and the files. Plus now I can do a slot that's recessed to accept the shoulders. The fit up is actually really good. The right side is bang on, and the left side does have a slight gap, but the day is young. This will only get better with time as I figure out how to reduce the chatter and the vibration. I'm going to get 3 more of these made up for the other blades and then get started on the handles. I mentioned earlier I'm doing a dowel construction for the tang glue up, and here's a tiny version to illustrate that because I just realized that I'm out of 1/2 inch dowels. Basically, this is a 1/4 inch dowel and about a 1/4 inch tang. I put a slot in here with my bandsaw, and behind the bolster, the tang will go into that slot and then as a unit get glued into a round hole in the handle material. And the reason I'm doing it this way with these knives is because these ones have an absolutely above average tang, and I'm also working with hard, dense ebony wood. So this is the only work I need to do to this material. I don't have to do any series of holes and connect them. I don't have to do any broaching. I don't need to do a burn-in. This is a preferable method for me, especially with a knife of this size. Now, unfortunately, my drill press doesn't have the clearance to go to full depth. I get maybe, I don't know, 5 or 6 inches, but it's good enough to get the alignment correct. So afterwards, I can come in and clamp this in a vise and use my hand drill to go to full depth. But that's pretty much it. I just have some quick polishing to do the glue up, the handle shaping, and we'll be good to go. Oh, what a week. It took me about 3 full long days to get all of this work done, where I've got one knife completely finished, and it is beautiful and it is dangerous. Now, I think that I've achieved my first two goals of making a tool that looks awesome, and now I have to achieve the third of selling these, which is the reason that I haven't finished these three. I'm going to take the finished knife as well as the almost finished knives to some potential customers. I'm basically going to cold call until I can sell these. And I'm thinking ahead that in my sales discussion, I'm going to show what I can do to add value, to not just sell a knife, but to sell a divide knife that's specifically built for you by putting in some custom branding and some custom names. So with that scrap steel I showed before, I cut them into little medallions, rounded out the corners, and I'm going to give this to the people that I talk to. And if they don't want them or the sales discussion doesn't work, no worries at all. I can just grind it off and try it again. This isn't going to be for everyone because it's a lot of work, but for a specific business or a restaurant that I have in mind, I think that's going to be pretty valuable. But the reason I'm doing it this way is because I'm a relatively new business, so I don't have a lot of visibility, but I'm really confident that I can make an awesome knife that works really well. And the best way to portray that value is to be able to see and hold a knife and cut with it. So I'm going to bring a physical one to them and say, this is what I can make for you, and I can have it ready in a couple of days if you're interested in this model. And if not, I can do a whole new one from scratch. But that's my game plan for these four. So I'm going to clean myself up, put on some nice clothes, and hit the road. So I've got everything packed up into my nice boxes. Time to find these some new homes. Wish me luck.